Hey, it's Coach Reeves here again, and today I'm going to do the review. I'm going to work about 12 out of the 20 problems. Hopefully, this will get enough to get you ready for the test coming up. Okay, let's take number one as it comes out. All right, so they're going to give us the function of x. They're going to get the function of g. They're going to ask us to find this. This because we have an open circle that's not multiplication. All right, so what we need to do is we're going to work it backwards. That's a composition of functions. So they're going to ask you to take the -4 and they're going to ask you to substitute it into the g problem. We're going to substitute it in g and get an answer. So this says, the g says we're going to go someone squared minus 2 times someone. On the previous test, I had a lot of students that did not substitute both places they saw an x. We have to substitute here and here. So I'm going to put in my 4x, and I'm going to put in my 4x. That's what they're asking us to substitute in. Well, 4x squared ends up being 16x squared. -2 times 4x is a -8x. This is my g answer. 16x squared minus 8x. They're going to ask me to take all of this and they're going to ask me to substitute it into my f problem, my f function. Okay? So what does that look like? Well, that's going to look like this. -2 minus 4 times someone. We have to put it right there. I'm going to take this g answer and I'm going to put it inside this parentheses because we're going to substitute for the x. So we're going to say 16x squared minus 8x. Bring down my -2. I'm going to distribute. I'm going to say -4 times 16x squared is a -64x squared. Take it to the back half. Negative times negative is a positive. 4 times 8x is 32x. Now that's an okay answer. That's a good answer, but it's not the way we want you to write the answer. We would prefer if you put smallest to the largest to smallest exponent, and the constant would be at the back end. We would prefer -64x squared plus 32x minus 2. Now, both of those are correct answers. This is the preferred form, but they're both correct. Okay? Let's go on to another problem. I'm looking at number 3. We still have the function of x and the function of g here, but look what they're going to ask me to do. They're going to ask me to subtract. So anytime they ask me to subtract, that gets my attention. Now that they have my attention, I look and they're going to ask me to substitute a variable. Now, when they ask me to substitute a variable, that means I'm going to take my f answer and I'm going to subtract my g answer, but I'm going to have to distribute the negative. You'll see what I mean in just a second, but let's take it one step at a time. All right, so we're going to substitute -2 into my f problem first. My f problem says -2 minus 4 times somebody. They're telling me to substitute in -2x. So I've substituted in -2x. I bring down my -2 and I distribute the 4. And I say -4, or I multiply, excuse me, don't distribute. -4 times a -2 is a positive 8x. This is my f answer. All we do is we substitute it in. This is my f answer. Now we have to go to our g problem. Our g problem says someone squared minus 2 times someone. Anytime that I have to plug in for a variable, I'm going to use parentheses so I can substitute. They're going to ask me to substitute in -2x. I have to put it both places. I square this. Negative 2 times negative 2 is a positive 4. X squared, or x times x, is going to give me x squared. Negative 2 times negative 2 is a positive 4, in this case x. When I multiply this, I get a positive 4x. This is the result of my g function when I substitute in. But they're asking me to subtract f answer minus my g answer. So I have to subtract here. So when I subtract, I must distribute the negative. So this is going to become, when I distribute, a negative 4x squared. When I distribute here, that's going to become a negative 4x. Let me move this just a little bit. So now we're going to combine like terms. When I combine like terms, I'm going to get a negative 4x squared. Look at these like terms. I have a plus 8x. I have a minus 4x. When I combine those, I end up with a plus 4x. And I still have the minus 2. There is my answer. Just to reiterate, when you have subtraction, that should get your attention. When you're going to have to substitute a variable, then you need to plan on distributing a negative and then combining like terms. Okay? Let's go to another problem. Now I'm looking at number 6. They're going to ask me to find the inverse and then graph it. I've got to find the inverse. To find the inverse, we're going to ask you to switch places with the x and the y. So we're going to switch places. This is going to turn into x equals 1/3 y minus 2. My goal is now to solve for y to get y by itself. So the first thing I want to do is I'm going to move the 2. I'm going to say plus 2 plus 2. This will cancel. I have x plus 2 equals 1/3 y. I need to get rid of this. I need to get rid of the 1/3 so I can get it by itself. We're taught to multiply times the reciprocal. When you get rid of a fraction, multiply by 3/1 in this case. 3/1 is the exact same thing as multiplying times 3, so I'm just going to multiply times 3. But this gets multiplied, this term gets multiplied times 3, this term gets multiplied by 3. The whole point is so this will cancel. That will leave me with my y by itself. X times 3 is going to leave me with the 3x. 2 times 3 is going to equal a positive 6. There is my inverse. Then they just ask you to go over there and graph it. We're going to start on the y-intercept at 6, or the y-axis. 1, 2, 3, 4, 5, 6. There's my starting point. My slope. My slope is always a fraction. This is going to tell me to go up 3 to the right 1. 1, 2, 3 to the right 1. If you run out of room, you can go the other way. I'm going to go down 1, 2, 3 to the left 1. We connect our dots, and that is the graph of our inverse. Switch the x and y, solve for the y value. Okay? Next problem. We're going to look at number 7. Number 7, they're going to ask us to find the area. They're going to ask us to find the area of that rectangle. To find the area of a rectangle, you're going to go length times width, base times height. Either way, you're going to have to go this side times this side. We've set it up for you. Okay? What I'm going to do, we're going to distribute. Okay? So I've got to take the x here. I have to multiply. Now remember that when you multiply variables, you're going to add the exponent. So this is going to turn into 2x to the third. When I multiply here and I distribute, I get a positive times a negative is a negative. X times x is going to give me x squared. I take it all the way to the back end, and I go x times 3 is a positive 3x. I have taken the first term and I have multiplied it all 3 places. Now I'm going to take the second term. I'm going to take the 4 and I'm going to multiply it all places. 4 times 2x squared is going to give me a positive 8x squared. Notice how I'm stacking my like terms. It's going to be easy to combine them in just a second. 4 times negative x is a negative 4x. 4 times 3 is a positive 12. I combine like terms. Nothing to combine with, so that turns into just a 2x to the third. I have a negative 1x squared. I have a positive 8. That will give me a positive 7x squared. I have a positive 3. I have a negative 4. That will leave me with a negative x and a positive 12. There is your area. Take your time, set it up, you'll be fine. All right, next problem. Number 9. We're going to solve an absolute value equation. Okay? My goal, I need to get my absolute value by itself first. So I'm going to have to move some things. The first thing I want to move is I want to move this 5. And I'm going to take the opposite, so I'm going to go minus 5, minus 5. This is going to cancel. That will leave me with 2 times the absolute value, x minus 8, equals negative 20. How do I move the 2? We're going to divide. We're going to divide by 2. We're going to divide by 2. That's going to cancel. That's going to leave me with x minus 8 equals a negative 10. Big question. My absolute value is always, always, always positive. Can my absolute value equal a negative number? And your answer is no, it cannot happen. This would be a no solution. Absolute value cannot equal a negative number. You shut it down and tell me no solution. Okay, let's go to another problem. All right, so we're going to solve an absolute value inequality. Similar to the equation, I still need to get my absolute value by itself. Got to get my absolute value by itself. Okay? So what are we going to do? We're going to move the 9. We're going to say minus 9, minus 9. This will cancel. I've got negative 2 times the absolute value minus b plus 4 is less than negative 8. Hey, we're still going. My absolute value is not by itself yet. So we're going to jump in here and we're going to divide by negative 2. We're going to divide by negative 2. This will cancel. That leaves me with the absolute value of negative b plus 4 is less than, oh, wait a second. What is the rule? We just divided both sides by a negative. What's the rule when you divide both sides of an inequality with a negative? You have to flip your symbol and point it the other way. So we're pointing to the left. So I have to flip my symbol and point it to the right because I'm dividing by a negative. A negative 8 divided by a negative 2 is a positive 4. Now my absolute value is by itself. I make a decision. Is this a workable problem? Because it's greater than 4. Yes. So I have to work it 2 ways. The first way we're going to work this, we're going to say negative v plus 4 is greater than 4. The second time, we're going to say negative v plus 4. Now the second time, we have to flip this symbol and take the opposite. This will be pointed the other way. It'll be less than, and then we're going to have a negative 4. The second time, you have to flip the symbol and take the opposite. So now we're going to go minus 4, minus 4. I get negative v is greater than 0, because this is going to cancel, but that's going to give me a 0. Okay, 0 is actually a number. You just can't stop and say no solution. But can I leave this? Can I leave this negative in front? This is a very tricky problem, tricky situation, and that's why we picked this problem. Okay? I can't leave this. So what I need to do is I have to divide by -1. When you divide by -1, this will cancel. That will be V. But again, what is the rule when you divide by negative? I have to flip my symbol again. This has to point to the left, and 0 divided by any number is still 0. Now my graph is going the other way. If you don't pay attention to these signs, you're going to miss the problem. Over here, -4, negative V is less than -8. Can we leave the negative in front of the V? No. So we have to divide by -1. We divide by -1. By dividing, we're going to get V. This cancels. We have to flip our symbol and point it the other way because we're dividing by a negative, and we get an 8. Can we graph that? Sure, if we needed to graph it, we could graph it. I don't think that they ask you to do so on this part of the other review, but hey, we're going to do it anyway. Just for extra practice, we're going to graph it. Who's smaller, 0 or 8? 0 is smaller. We put a circle. Should I color my circle in? There is not a bar, so we do not color it in. If we're lucky enough to where the variable's on the left, then this symbol will tell us which way to go on the graph, because it says my V values are getting smaller than 0, less than, which means they should go to the left. All right? We're over here. We put a mark. We have our 8. We put a circle on it. There is not a bar, so we do not color it in. We are lucky enough to where the variable is on the left. It says my V's are going to be bigger than 8. They're going to be greater than 8, so as I go to the right, they get greater. This is what a graph would look like if they asked you to graph it. I'm not sure if they asked you that on this one. Okay, we're going to go to another problem. So now we're going to solve this one. Okay? We have to get absolute value by itself. So the first thing I want to do is I want to move the 7 to the other side. We're going to go -7, -7. This will cancel. This is going to leave me with the absolute value of V plus 4 over 2 is greater than or equal to 1 minus 7. What is 1 minus 7? That's going to give me a -6. I need to get rid of the 2 in the denominator. To get rid of the 2 in the denominator, we're going to multiply times 2. Multiply times 2. This is going to cancel. That's the whole point of multiplying times 2. This is gone. That's going to leave me with the absolute value of V plus 4 is greater than or equal to, what is -6 times 2? That's going to give you a -12. Now here's where it needs to get your attention. There's some kind of red flag needs to just shoot up in the air and say, oh, I have a negative number. When you're dealing with absolute value and you get a negative number over here when you're by yourself, when the absolute value is by itself, you get 2 choices. Your 2 choices are no solution or all real numbers. Think about this, okay? We know for a fact that this is going to be positive. Absolute value is always positive. So if this is a positive number, what positive numbers are going to be bigger than -12? Think about it. What positive numbers are bigger than -12? All of them. If you're a positive number, you've got to be bigger than -12. So in this situation, this answer would be all real numbers. That's how this would work. Now, I know this is not on the review sheet, but I'm going to give you a what if. What if? What if this was less than or equal to? Is it possible for a positive number to be smaller or less than a negative number? No. In this situation, you would tell me no solution. Okay? But on your review sheet, the actual problem says greater than or equal to, and your answer would be all real numbers. Okay? Think about this. Absolute value, and you get a negative number, you get two choices. It's either going to be all real numbers or no solution, depending on the situation. Okay? Moving forward. They're going to ask me, we're going to have to write the equation. Okay? This is number 13. They're going to ask me to write the equation for this graph. Okay? Looking at this, I know my equation is going to start y equals. Yay! But it says that I went to the right 3 and up 2. I went 1, 2, 3, 1, 2. I'm right there. Okay, so if I went to the right 3 and up 2, how would I write that? We would say inside the absolute value, you're thinking opposite. So this is going to be x minus 3. Since I went up 2, which is my k value, we're going to go plus 2. But now I need to find out my a value up front. I need to find out what we call the slope sometimes. You're going to find out that we went up 2 to the right 1. And if you go up 2 to the right 1, that would put a 2 in front. This would be the equation of that graph right there. Okay? Are we good? All right, moving forward. Number 14. They're going to ask us to write in interval notation. They're going to ask us for the domain and range in interval notation for this. This is the trickier of the two problems on the review sheet. So I grabbed this one to do for you. Okay? For domain, I need to look at my left edge. All right, it looks like on my left edge, I'm located at -4. Okay? So the left edge is at -4, so that means I'm going to have a -4. But I have an open circle. That open circle means do not include, which means I'm going to get a soft bracket because we actually do not make contact with the line. All right, so we're going to travel, we're going to travel until we get to this next open circle. So we're going to go from -4 until we get to this point. And that point happens to be located at -2. But there's an open circle, which means do not touch or do not include. So that would get me another soft bracket. But there's a big gap. It's like walking down the street and then there's a hole in the ground like a manhole and you have to step over. All right? But to continue our journey, we're going to need a U or a union to continue to hold everything together. Okay? So we step over, but we continue on our journey. We pick up our journey at -2. And we're still walking, we start walking, and we get over here till we get to another open circle. And that open circle is located at a +2. But since it's it's an open circle, means we do not include that one. So you have to have another soft bracket. So we have this big hole in the floor again, and so we have to step over it. We're going to need another union to keep us going. We continue our journey at 2, and look how far we go. How far to the left, or to the right do we go? We go to the right for infinity. So we're going to come over here and we're going to say comma, infinity. There is your domain in interval notation. Anytime that you have an open circle, you're going to end up with a soft bracket. Okay? All right. The range. The range is a lot easier. Range talks about your y values, how high and how low you go. In this case, how low is this graph going to go? Does my graph stop here? Or what does this arrow mean? This arrow means it keeps going on, going. Even though this circle is here, this side of the graph keeps going down forever, which means we're going to be at -infinity. We're going to go down into the negatives or get smaller forever. How high do I go? Well, this is the tricky part for some people. The high point of my graph is right there. All right, and you have to ask yourself, does our graph make contact with this line? Well, this point says no, we don't make contact. This point says no, we don't make contact. But right here, do we make contact? Does our graph make contact with the line? If at any time that you make contact with the line, you have to count it as a touch and you have to give it a hard bracket. So even though you have open circles here, you actually make contact with the line here, you have to give it a hard bracket, and we're going to be at a +1, but you got to give it a hard bracket. Okay? There's your range, there's your domain and interval notation. All right, let's keep going. Number 16. They're going to ask me to solve for this. And I'm going to tell you right now, when your variable is outside, when you have a variable that is outside the absolute value, you better make sure that you check for an extraneous solution. Okay? So, absolute value is by itself, so we're going to work this two ways. Okay? The first way we see this, we're going to say x plus 3 equals 3x minus 1. You just copy it just like you see it. The second time we work this, we're going to say x plus 3 equals, we have to take the opposite of both of these. This is becoming a negative 3x. This will become a positive 1. You have to take the opposite of both. So now we do the math. We work a little bit. We're going to say minus x minus x. This will cancel. Okay? This is going to leave me with a 2x. We're going to move the 1 to the other side. How? By taking the opposite. Plus 1 plus 1. 3 plus 1 equals 4. We divide by 2. And we find out that x will equal the number 2. Now we're going to check this to see if this makes a true statement. See if it works. So we're going to jump up here and we're going to say 3 times 2 minus 1. 3 times 2 is 6. 6 minus 1 equals 5. So we take our 2, we put it right here. 2 plus 3. 2 plus 3 is 5. The absolute value of 5 is 5, so this checks. That's a good answer. Okay? We work the next problem. Move this over here. We're going to say plus 3x. That's going to give me a total of 4x. We move our 3 to the other side. We move it the other way. We're going to say minus 3, and that's going to equal negative 2. We're going to divide by 4. And when we reduce, we get x equals a negative 1/2. We have to see if that's a good answer. So we're going to go back up here and we're going to substitute. And we're going to say 3. Let's go ahead and give us some room. We're going to say 3 times a negative 1/2. And then we're going to subtract 1. Now, why did I substitute here first? Absolute value is always positive. Always positive. It can never equal a negative. So if I take this and I substitute it here first, and this ends up being a negative, that's a bad answer. That's an extraneous solution. Because absolute value cannot equal a negative number. You always substitute over here first. Save yourself a little bit of work. Okay? 3 times negative 1/2 is a negative 3 over 2. When you subtract 1, that's going to equal a negative 5 over 2. Can my absolute value equal a negative number? Your answer should be no, which cancels out this answer because it's extraneous. This is the only good answer that you should write in the blank. Okay? Yay. All right, going on. Number 18. We're going to solve an inequality. This time they ask us to graph it. So we're going to graph this guy. Step 1. Step 1, we're going to move the 4 to the other side. We're going to say minus 4, minus 4. This is going to cancel. That leaves me with negative 2, absolute value of a minus 5. is greater than, that's going to give me a negative 14. Still need to get my absolute value by itself. So now, I'm going to divide by negative 2. Oh, that's right. Divide by a negative number. So we're dividing by negative 2. Divide by negative 2. This will cancel. I'm left with a minus 5. But since I divided by a negative, I have to flip my symbol and point it the other way. This is going to be less than. A negative divided by a negative is a positive. That's going to get me a 7. Now we're ready to work the problem. Absolute value is by itself. We're going to have to work it two ways. The first time we work it, we're going to have to copy it. We're going to say a minus 5 is less than 7. The second time we work this problem, a minus 5, but the second time we have to flip our symbol and take the opposite. This will be greater than negative 7. Plus 5, plus 5. This cancels. I get a is less than 12. Plus 5, plus 5. This cancels. A is greater than, look at that, that's going to get you a negative 2. These are my two answers. They're going to ask me to go over there and graph them. So we're going to go over here and graph these. We're going to say, who is smaller, 12 or negative 2? Negative 2. So the smaller guy, the negative 2, goes on the left. I put a circle. Should I color in my circle? No, because there's no bar underneath there, so it stays an open circle. Okay? My variable, I am lucky enough for my variable to be on the left. Remember, if you're lucky enough for your variable to be on the left, then this symbol will tell you which way to graph. It says the A's are getting bigger, so we go to the right, but anyway, this tells me to go to the right. Okay? It says A and 12, so we're going to put a 12 over here. We're going to put a circle on it. There's no bar underneath, so we're not going to close it in or color it in, okay? And it says, again, we are lucky that the variable is on the left, so this symbol will tell us which way to go. And it says we need to go to the left. But anyway, we know that the A's are less than 12. They're getting smaller, so we need to go to the left. Since my graphs are going towards each other, we're going to use the word and. Remember, if they go away from each other, you use the word or. Okay? So this is considered your solution. This is the solution that you're looking for. This is the graph of your solution. Two different things. Solution, graph of the solution. Okay? All right, number 20. They're asking me to find the range as an inequality and an interval notation. Two ways. All they're asking is find the range. Okay? It's easier if you find it as an inequality first and then transfer that to interval notation. That's just my opinion. Okay? So the thing is, we need to look at two things. We need to look here and we need to look at the back number. Okay? This tells me which way my graph is going to open. This is a positive 2. So it tells me my graph is going to open up, which means I go up forever shooting this way. So my range talks about my y values. Okay? We'll put it over here. My range talks about my y values, and since my graph opens up, we're getting greater. We're getting bigger. So we're going to say greater. Now, no matter what, all my graphs will make contact with the line. No doubt about it, we're going to make contact with the line, so we're going to get greater than or equal to every time. You don't even have to worry about that part. Then it says, how high do I go? There is your height. This is your K value. It tells you how high or how low you go. This says we're going to be located at negative 6. There is your range as an inequality. Not so bad. All right? Now, here's what you need to understand. Anytime that you start with your letter, that means you need to include an infinity. You need to include infinity if you have a y in your answer, okay? Now, since we're going up forever, that is positive infinity. If we were going down, that would be negative infinity. But we're going up, so this is going to be positive infinity. And we're going to go from positive infinity to where? We're going to go to negative 6. But there's a bar underneath, so that means we get a hard bracket. That's a good answer. But a lot of times we would like for you to go smallest to biggest. So if you were just really worried about the detail, you could write it the other way and you say, okay, I'm going to start at negative 6 and then I'm going to go up forever to infinity, and we could write it that way. I would take either one of those. I would be tickled to death if you gave me the right answer. Okay? All right, so that's all we got. We've got 20 problems. So I have just worked 12 out of the 20. That left you 8 to kind of kick around and try on yourself. Okay? So you're going to get this Thursday. Tonight's Wednesday night. You're going to get this Thursday. I really, really need you to try to do your review sheet over the weekend. Okay? Now, what we're going to try to do, we're going to invite you to a Zoom. We're going to invite you to it's not our normal thing, but we're going to invite you to a Zoom on Monday. Okay? The test is Tuesday, but we want to ask you if you'll show up and take a Zoom and come to class on Monday so we can go over the test with you and we can help you review and maybe answer questions about the review sheet. But we want to go over the old test so you make sure you don't make the same mistakes twice. Okay? So if you're watching this, thanks for watching this. Hey, try the review sheet. Email us if you have questions or circle them. And then if you attend the Zoom on Monday, yay. Okay? We'll help you then. All right? Good luck.